Today, we'll be talking about databases and before we get there we go. That's what I needed. All right. All right. So, what is a database? Anybody can help me with why do we even use databases? What is in a database? And do you have any knowledge or experience in using a database? So the first question is, what is a database? Okay, we'll wait for everybody to wake up. What is a database? Okay, so,
Collection of information,
say again,
huge collection of information.
that's it in a nutshell, huge collection of information. So if it's collection of information, all right, info. All right.
Details.
So, yeah, so what are some of the details, like, so when you have a database, you have information in this database, how is this database organized? How is it structured? What kind of information? Because you can put a lot of collection of information in a database, but then, so then why you need a database? Because I can collect information anywhere, but I did ask the pointed question of what is a database, and what we got was a collection of information, which is correct, but why a database? So why are we collecting information in the database?
So we can have it organized and easily accessible.
Yeah,
Remember everything, what you know about what's important?
yeah, all that information is still collected. So what I'm trying to get at then is, when we have a database, does anyone know how we get the information in the database? Since we're collecting all this information, let's use it for example, so you can kind of hone in. Let's use Gwinnett Technical College's database. What information is collected in Gwinnett Technical College's database? Obvious answer.
Grades, transcripts,
Hello,
names, address,
student information.
all that.
So now we getting somewhere. So not only are we collecting info, we're collecting a certain kind of info for a particular database, and let's call it student info. Now we're getting a little more down the line. We're not just collecting information, we're collecting student. So if we're collecting student information, and that includes with grades, what else? Anything else under student address?
Transcripts, previous high school
Classes.
Yeah, so history, let's call it school history. What else?
Classes.
Anything else you could think of?
Courses.
Courses, exactly. So now our database is starting to look more like what kind of information we're collecting now. And that holds true for any database. If you have a database, the information that you're collecting in the database should reflect your population for the most part, okay? And so when we go into collecting information, and more importantly, student information, and all these things that fall, an instructor, right? When we get to collecting that information, still, do anybody know how we get that information into a database? The method of how you get information into a database? Good morning. So every database, right, a real database is gonna always collect information constantly. So if it's collecting information constantly, what's the best way to put information into a system? So let's go, you filling out a Spotify account, and this is just fictitiously. And when you you create a Spotify account, what are you doing?
Email, you're adding.
Okay, and where are you putting this information into? Into a database, but how are you I'm trying to get y'all to think about how the information gets into it. So when you go into Spotify, what's the first thing that happens? Ask for your email. What does that look like? It's a field, isn't it? It's a blank space where you put it in, right? You don't just type your email in and your phone number and your name and all that. There are fields that ask you for that information, correct?
Yes.
Okay, so when they ask you for that information, they're collecting the information through a form, right? And that's no matter what you do, you collect it. That's the way you get information into any database, is through a form. So that's important. A form. Because, you ever heard of this? Anybody?
Database management software.
Right. So if you know that and you understand that and you got a little bit of that, to have a database, what comes with the DBMS system is a form generator. So whatever information you're collecting, you have to do it through a form. You can't willy-nilly, someone comes in and you start typing their address into a Word document. You gotta have a way of collecting that information as new information comes in. There's a way to do that, and that's why the DBMS has the form generator or application generator, whatever you want to call it. But the bottom line is it allows you to collect the data in a form. So why would it do that? Why would it even suggest a form?
So it can take the data.
Yeah.
And
Taking the data.
save it.
Yep, and so as you collect the form, you save it. Also what it does, this is why it's important for DBMS, and to have that, a part of that system, is because we human beings, right? All of us are human beings, we're not computers in here, right? So as you're collecting data, you're prone to make mistakes. And the less you can make mistakes, the better the data is in the system. So the whole point of the form is to cut down on making a lot of mistakes when you're typing in addresses and things like this and so forth. So with that being said, and you have that information in the system, hopefully it'll be in there correct, but at least if you're collecting the information, let's say you try to put, and I'm gonna go there, character, and what else we have? Table. What else we have? Anything else? else, any other items you read about that matter when it comes down to a database? So I got my old book out, cause I'm a try to help you with this. So, at least better understand it from my perspective. You have a character, you have a field. We just talked about forms, right? I think I'm spelling that right. F-I-E-L-D, yep. You have a record. I went too far, right? Record. And then a table. Anybody can tell me about any of these, I guess what I'm gonna call it, characteristics of organizing data in a database. So we are talking about databases. So the whole point, so I think someone mentioned is organized. I think someone said that. So when you're trying to organize your data in a database, it has to follow certain standards, right? So a character, if we talk in data organization, I'm sorry, all right. So what's part of organizing data from a standard?
What does that you run on the top, Mr. Edwards?
Say again?
Let's say data organization.
Yeah, data organization, sorry. I kind of bunched it together.
No, it's my fault. I didn't know what it was. I shouldn't have asked.
Yeah, you're good. All right, so in data organization, so when you understand databases, you gotta know what a character is. So anybody can tell me about a character? We are still talking about data now. So when you speak in character, what are you talking about when it comes down to, or what is a character when it comes down to data? What is a character? Does those look familiar? Those are characters. What's the first character up there on the board? A letter. Single letter. What's the second character? A number, right? So what's the third character? A symbol. So, in your learning about the databases, it's gonna ask you about characters, and characters are the most basic logical data element. A single letter, number, or special character, punctuation mark, symbol, blah, blah, blah. Why is that important to know? No? Okay.
That's what you're interested in.
Exactly. So when you have a single character, and let's call it the field. So what the field is a group of related characters, right? And it says that the last name of employee, blah, blah, blah. It goes on and starts to talk about that. A data field represents an attribute, a description of characters, or some entity, person, place, or thing. So if we're saying the field, good morning. In the field, this field, depending on what kind of characters you're gonna put in that field, is gonna determine what the field will accept. So if you ever seen a field, we talked a little bit about forms, but in a field, a field will look like this right here, right? For example, you have a whole bunch of fields with different titles, if you will. Like, let's call this address, the address field. All right, y'all follow me so far? So if you have a database and you have a form to fill out, the form has a bunch of fields. So let's start off with a person's first name. So the field would say, well, we said address, but let's do one over here. And call this, I'm just gonna say FN for first name. What kind of character will fit in a first name field?
Letters.
Letters, right? So when this is set up, first name is gonna be letters. So what is letters called? Characters, alpha characters, right? So you have a first name, that the type of data or character that would go in this field will be an alpha type. Right? Field. Sorry, I'm bunching stuff together. But, so, let's say first name John. I'm gonna keep it real simple. John. Now, if, according to a database, if I was to put John the second, will that work? It will not work because remember, or why would it not work?
Because you characterize the field with number.
Right, because it's an alpha type field. So since it's an alpha type field in a database, in order to make the database proper, if I just go and I put numbers and letters and put whatever I want in the field, it's gonna make it confusing. It's gonna make the database information confusing. So if I'm telling you that, or I'm setting my field up to only accept alpha type characters, then if you go try to put this in there, it's not going to accept the entry. It's going to say error. And it's going to put it out there next to it, and it'll tell you why. And it'll probably have that number 2 sitting out there or whatever. But the point is, when you're looking at a database and you're setting up a database, you want to know what character type you can put in that field. For example, another example, how about address? Can I put just alpha type characters in an address field?
No.
Why?
Because you gotta get specific, you gotta put street, you gotta put your street.
The numbers. So yeah, so you're looking for that kind of data in that field. And if you have that field set up to accept both numbers and letters, then it's not going to accept it. So that's how database works. So what kind of field would this be then? It's including letters and numbers. Thank you. Alphanumeric. I'm sorry I'm writing crazy, but I'm trying to hurry up and do this to cover. So alphanumeric. So that way you can put in 1, 2, 3, B, byway, street. What about a zip code? How would you identify that type of character? Numeric, right?
1, 2, 3,
Have
5.
anybody seen letters in a zip code yet? Nope. Not yet. So that's another field. Now, we're gonna get a little interesting on you. Here's another field. And I'm gonna tell you what the character type is. You tell me what can go in the field. So I'm gonna name this type a string character. What typically, anybody knows what will go in a string character type field? Summer. You can do symbols. You can do, a string is good because really you can put alpha, you can put numeric, you can put alphanumeric, you can put symbols, you can put whatever you want for the most part, you know? Now, here's the other part about databases and field types is you have to give it a number of characters. So first name, what's a good length for a for a first name? Anybody?
7 characters?
7? What if you're African?
Then 10 or 12 then.
I'm just trying to get you to think through when you doing a database, when you creating a database. So you got a database, you got to know what you're looking for, and so
I think most of them might have a max of like 20, I think.
so it just depends. So and how the person that's setting up the database, what characters, the number of characters they allow. Because we had a situation, believe it or not, we had a student that had a 1-letter first name. We wasn't expecting that in our database. So we had to go back, because a database administrator can make the adjustments to the field, the lengths, and things like that. So just keep in mind, your best shot, Kevin, your best shot, let's say your best shot is 7 characters, and you find out you got a first name with 8, 9 characters now. As a database administrator, you can go back in, edit that first name field, and make it long. So keep that in mind. So that's why databases are flexible also, because you can make them do what you want them to do, okay? So that's the character part. This is the field part. So whatever field. So as you start accumulating first names, of course, and last names, as you start accumulating, you may get 10 Johns in your database. How you separate the two. First name, last name, same.
Middle name.
Middle name, first name, last name, middle name, the same. I would challenge you to think, because that's the whole point of a database. Because it's your data in there, and the number one objective on a database is to eliminate duplicates.
I guess birthday.
Birthday, what if they twins? I'm just trying.
Social.
Now you're thinking about more,
They can have the same social.
right, more unique things. So when we talk in databases, the whole point of identifying a record, which is the next thing we're gonna get to, is it has to have a unique identifier. That's what we call it. And that unique identifier, especially with a database of names, social security number is probably gonna be your best option to make that what we call a primary key. Because that primary key is what you're gonna search on to find any student in your database, regardless of what's all the same. The one thing that's not gonna be the same, is which is why it's called a unique identifier, is gonna be your social security number. Okay, students, what's gonna be your unique identifier number?
Student ID number.
Student ID number. So now we know, I can pull you up and separate you from anybody else with your same name, whatever. Because that way I can get the record that I'm looking for. So that's how we identify records in a database, is with the unique ID. And whatever it is, then that's what we're gonna go to search on, because you gotta search on something to find the record you're looking for. So what is a record?
A list of important information.
Yeah, you're right on it. So a record, if you go down, a bunch of characters create fields, right? Different characters in these fields. So a bunch of characters create fields. A bunch of fields create a record. So first record, record 1, John II, Malcolm. John Malcolm, address 123, blah, 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 zip code, blah, 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 and whatever else in there. That's my first record. All those fields combined together create my first record. So, I need this in my hand. Alright, so usually you'll see in the database, I'll show you shortly an actual database, but I just want you to keep in mind, as you accumulate, you start building. And so records, I'm just gonna put a 1 here. That indicates that's my first record in my database, okay? So in a database, any database, well, anything that counts numbers of files, whatever, always gonna keep a record of it by a first row, a second row, go on and go for. How many entries you have in your database is gonna be indicative of how many numbers you have, or how many objects, if you will, in your bed. Like if I got a database of 500 students, right? I'm gonna have 500 lines in my database, okay? And so that's how you equate that. So that those are 500 lines are really called 500 records, okay? So, and the records contain all of the first name, last name, address, zip code, blah, 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 of those 500 students, right? So those are the fields, that all those different fields, when you combine them, you get one record with address, name, blah, 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 like that. Once you do that, and you have these records, and like I said, 500 records, those 500 records can be put into a table, right? So according to the definition of a table, let me find it, make sure I'm saying it right. A table is a collection of related records. So let's say you have a, I don't know, a student database, right? So that student database will have tables in it, right? It could have students' grades as one of the tables. It could have the student's address as another table, right? And so on and so forth. So as many fields as you have, first name, last name, so a name database would have all of that information on it, but to put it in a table, say you just wanted all of the addresses for the students, you can actually create a table with just students' addresses in it. So that's kind of how a table is developed. So if you think about it, like I said, a bunch of characters create fields, a bunch of fields create a record, and a bunch of records get put into tables. And why do I separate it by tables? Why I can't just say these are all records?
Not specific.
Yeah. And another good thing too, you want to create some kind of separation of different data. Because you don't want to have a table, a database with just all the information, all of the information in it. You want to break it down a little bit, so like you said, so if it's detail you want, a database is supposed to give you that. So what's the point of a database? We query databases, correct? So when we query databases, we're looking for something in particular, right? Or we're searching for a group of these things. And so in order to do that, you make it easier on your database and the query to be able to kind of segment things so it's easier to find. Versus, think about it this way, is that if I just have the records and I'm searching through all of these records for a student address, that means the amount of data, the database, which the database does this with no problem, but it makes it less confusing on the user when you go through a database and you're searching for addresses and you get addresses only, right? Because now you're just looking for a particular students that live on this particular street or this specific city or whatever. You can do that because you have all the data. But when you separate it out and put it in tables, you make it easier for the person that's administering. So a database administrator you don't do this, the database administrator is gonna make the tables. And the tables gotta interconnect, for another good example that I can think of just off the top of my head. When you're driving, your driving record. So you have, the DMV has a database with just your plates. Just when they pull the car, make and model of the car. All this is in a separate database, so that way, if you get stopped by the police and they run your tags, they'll see more information. And that's really a relational database, because what that does when you run that plate, when they run that plate, it ties it into your residence, where you live. The DMV has all of that on you. Social security number, driver's license number. Matter of fact, did you get a speeding ticket? So that's a whole different database. That's a citation database. All these are tied in, and that's the glory of a database. You don't have to have all the information in one database. You can collect it, but 9 times out of 10, the best databases cross-reference with each other. And when they cross-reference for a reason. If we're driving, we talk about traffic violations, So that's why it would tie into that database, okay? So I think that's kind of the nutshell of data organization and how it gets to where it is when you have data in the database. So the only other thing that I want to add to this is physical. They have what they call a physical location, and anybody know the other one? I gotta find it. Physical and a logical location when it comes to data. So a database administrator is more obsessed with the physical location of the database. Why? Because physical is where it's being stored, physical. As a database administrator, any of us in here, hopefully if you understand storage, when you start talking about database, I said at the beginning, it keeps adding to the database. You keep adding data. Every time a new student comes, they get added to the database. Anytime you do things at work, your job description gets bigger, and that gets added to a data. When that happens, that's more information. When that's more information, what does that mean for you, according to storage-wise? So why does it matter to think about your storage when you have a database? I'm sorry? You start using up storage, period. So eventually, as you add into your database, it's gonna keep growing. It's not gonna go, okay, he's added another student, let's get rid of another student. That's not how it works. A database is your, what is it, Kevin, your database? A collection of information. So if you keep collecting information and you're not getting rid of any information, guess what's happening to your storage space?
You'll run out.
Is getting smaller. So that's important when you start thinking and talking databases. Is my database administrator is going to be concerned with my physical location, because that's where I'm storing all my data. And eventually he's going to run out of space. So a database administrator will tell you stuff like, do you need that information? Because they're always thinking about how they're going to store it, because they gotta manage the storage for the data. And eventually it's gonna get smaller and smaller if they're not managing it properly. So that's the physical location. What about the logical location? Anybody? I'm trying to find it. They call physical views and logical views. So I'll read it a little bit. The physical view focuses on the actual format and location of the data. So why do I care about format then now? It goes back to what I was talking about, alphanumeric. It matters. And so when they say that the physical view focuses on the actual format and location, that's exactly what they mean. Because in a database, if your formatting is not correct or set up properly, you're gonna have mismatched data. You're gonna have data that doesn't make sense. But formatting, if everything is kind of formatted in the same format, then you don't have to worry too much about that part. Morning. All right? And so the logical view focuses on the meaning, content, and context of the data. So that's what most of us are concerned with. The logical view. What does it look like? How does it make sense? Database administrator is more concerned about where we're putting this stuff and is it in the right format. Okay? And then we talked about primary. Let me move on. I don't have my pointer today, I'm sorry. Let's see if we can move on with that. So we talked about DBMS. That's the symbol. Anytime you see this, like stats, like this here, this just says this is an Excel database, access database, sorry. And it has these 3, 4 drums stacked. Anytime you see the symbol, that represents a database. That symbol does. You might want to know that. All right, these are some of the ones. MySQL, Oracle is a big one. That's a corporate, more of a corporate. Most corporations use Oracle. We have Oracle as our database. And so that's the standard. Database right here. So, this is an example of a database in Access. This is an Access database. This is a database that's typically intended to be smaller in nature, to handle more personal type data versus Oracle, which is a bigger database and it does more things. But all databases do the same thing, but at what level and the amount of data that you have to handle becomes a difference, all right? So as we can see here, what kind of fields do we have here? Okay, by the way, before we start, this is a employees database. Okay, so this is a database of employees, all right? So what are some of the things? I already pointed most of them out, but I didn't point out is things like location, hire date, birth date. Everything else we kind of talked a little bit about. I didn't say state. So again, in a database, you can make a database have what you want it to have. That's the data you want to collect, okay? And so that's what matters. And what matters also is in the last name field, you don't see anybody with with numbers in their name. Same thing with first name. You don't see nobody with numbers in their name. Here, you don't see any letters, so you know what kind of field would be the hire date. You know by looking at that. As a database administrator, you know that has to be a numeric field. So you can't put nothing but numeric data in there, okay? Address. Like we said, you have numbers and letters, so that's more of an alpha numeric field because it combines and does both. So that's how that goes. Any questions? Database. What does this say? So price could be example. It could be an example of a string field. Why? It contains a dot, it contains a symbol, and it contains numbers, okay? So that's a good example of a string type field in a database, okay? Let's see what else. And so those are the products. So we went from employee to products. Now that's your products, what? Table, right? So all the products that you have are in a table. That's what I'm talking about by separating and making a bunch of different tables based on what you have collected data on, okay? All right, so here's the form. So I talked earlier in class about forms. So you gotta have a way to input the data for the database, right? So this is the employee form. You see that there, form? So that's where you will put, you can put your products, your orders, your customers, your employees, you can put them all in also in a table, but you could create a form for that with a DBMS. And this is what one of the forms look like for the employees. So this is the data they will collect for any employee that comes in, any new employee that comes in. Can you see something that will help me, even though this is a small database, but will help me to identify? Could I add something here to the employee form to help me uniquely identify each employee?
Yeah.
What would that be?
So,
Or it could be employee ID, whatever, but I'm just letting you know, as a database, these are the kind of things you can do in a database. I don't have that here right now. I only have 15 employees, but what if I get to 1,500 employees? That database doesn't become that simple anymore. So you gotta have something to identify each employee, and usually it is a social security number, but nowadays, we dealing with a lot of PII information being put out and personalized. So to me, an employee ID number would be a little bit more soothing, because you're not putting somebody's social security number out there. Because just because this is a database management system, that doesn't mean that someone that is working in this and has access to it is not gonna take the social security numbers.
yeah.
Yes, sir.
Would a social be considered a primary key?
Yes. It would. But so again, like, if I pull up any of you students in here, I don't have your social, I don't have access to your social. I have access to your student ID, but I don't have access to your social security number. So that's my point. So when you create a database, try not to put somebody's social in any mix that you can think of. Try to leave the social out of it. Give them a whole nother number. Give them a number, you assign the number. You can have this system in the DBS as you put in or add fields, right? As you add fields, that's what these are, individually fields. As you adding this to create a record, you can actually add that ID number, whatever that is, as one of the fields here. So that'll make it easier on you to identify. Now you can identify by the employee ID number, like students. I identify you guys in a lot of my databases by your student ID number. That way I won't get it mixed up with another student. That's what's important. Any other questions? Or any questions? All right. So we did this. Tables, we got tables. Queries, anybody know what a query is? We just talked about it. It's just the search. When you query it on something, you're searching for information in your database. That's all that means. So you can run all kind of queries. There's some automatic queries you can run. And once you run a query and you filled out forms, information for people, employees or whatever, in a form, once you do all of that, how does reports play a role now? So I might need a report. I might need to know how many of my employees, like I said earlier, live in a certain zip code. I can query that and get a report for that. And it'll show me just those employees. It won't give me a report for all my employees because I'm not asking the database for that. I'm asking the data for how many employees live in zip code 30233. And it'll give that to me. So that's the power of a database. You can get the results faster by doing a simple search. And you can comb through a lot of data. I have some data that I pull in that has 10,000 lines of data. I'm not searching through all the lines for what I need. That's not gonna happen. I'll still be there looking for that data. So do you know like in anything you pull up, an Excel spreadsheet, but the database makes this come to light. But if you have an Excel spreadsheet that has a lot of lines of records and things like that, you can do a Control F. What that means is find whatever I'm getting ready to type in and say next. And instead of going through all that information, all that data, you do a Control F and type it in. What it'll do is give you the first occurrence of whatever you typed in. And then if you say next, it'll take you to the next occurrence of that, and so on and so forth. That's a whole lot easier search than taking my eyes and wearing my eyes out looking through a whole bunch of data. So it helps you, and Excel spreadsheet is really a database too. But we don't talk to it about it like that because it does some more specific things as a spreadsheet, you know what I'm saying? That a database won't do, okay? Like calculations, formulas, things like that, your database is not gonna do that. But your Excel spreadsheet will do that, and that's why most people use it, and you can manipulate it, just like you can manipulate a database, but a database is faster, because it don't have to worry about calculations and formulas and things like that necessarily. So if you care and dare to do it, this is an in-class practice, kind of sort of like what I gave you as practice for when I was out. I gave you some in-class practices for you to do. By the way, how did that go? Did anybody really do any of it and learned anything from it? Because that was the real point, was just the learning how to get access to certain things.
I've been doing every live.
You did every one of them? As you've been doing?
Well, I've been doing every live as I go through the course.
That's good. So how do you find, like, so without doing it actually in class, how do you find them to work for you? Because they should be pretty straightforward. Now, I've had some students struggle a little bit with the labs, and that's only because it's just a new, because the simulation is not as easy to navigate when you first trying to do it. And some labs are a little more complicated than others, but nonetheless. So this is supposed to help you. So I would suggest, if you don't know anything about databases, besides what you heard today, I would do this in class practice. And then if you have questions, we can come back to that and you can ask those questions and we can get a better understanding of what it is to have an Access database. I tried to do an Access database for my music until I found out my DJ software does it for me. Then I didn't have to recreate the wheel. Speaking of that, well, this is a good point to stop and show you that real quick. So this is a database also, and besides, before you look at this, don't judge me. One, by how I use the database. Two, the records and the songs that I have in my database, okay? So just keep an open mind about that. Let's see. All right, laptop. So, Serato, standard DJ software, okay? Why is this a database? I'll first by asking you that. That way I can see if what I said makes sense here. Why is this a database? Say again?
Keeping track of the stuff that you need.
It's keeping a track, it's organizing things. So okay, so here's the question I get most students on. This is a music database. So what would be my unique identifier?
The one on the left. The numbers.
Here?
Yeah.
That would make it?
I think that the first one should be the, I don't know how to put it. The first one, the type of music. No.
Which one? Here?
No, the type of, no, your left.
Left. Here.
Yeah.
Okay, so this would identify
Yeah, and what music you want to play or something like that.
Okay, so what if I have, thinking database? So the database is containing all your information that you're collecting, like you said, Bernard. But what if I have two songs that got the same name in one of those categories you're speaking of? So let's say there's an R&B song named Happy, for example. Then there's a hip hop song named Happy. How do I know which one? Good morning. How do I know which one I want? Or which one I'm searching for? I know which one I'm searching for, but if I do it based on that, it may come up with 5 different happys. But I want one of those happys. Now, it's okay if those are the same, and I'm pulling it up, because that's what a database is supposed to do, show you what's redundant in the database. And that's okay if they're the same, because I can either delete it, or I can name it something else. So, going back to the unique identifier, anybody else?
Album?
Album?
The artist,
Is it the key?
the artist,
Maybe the,
I have to think about that for a second. But honestly, I wasn't prepared to. Let me see, hold on.
I think you put up the title of the song and then as you do the DJ, you know what type and what type of song you are looking for.
Yeah, but at the same time, as a DJ, sometimes I hear so much music. If someone comes up to me in a party and say, "Hey, do you have so and so?" I don't know if I got it or not. I got 40,000 songs.
I just ask who play,
Huh?
the writer, I mean, the songwriter, and so that I can say.
You can do that, but if you DJ in a party, that's gonna take a while.
But why wouldn't the unique be the 80s and the 70s? Wouldn't that be like
Because if I'm looking for something specific, that means I have to search all that data. So 80s and 90s just telling me, in this definition, is just telling me all the songs that I have in a database that are from the 80s. You see what I'm saying? So what specific song am I looking for? So hopefully, I pulled this up. This is part of the database. Everything that's checked, there's a column for everything that you have a check next to. Some are not checked. So, thinking about what I said about uniqueness, a way to find songs in my database, what would I do? How would I do that? Those are only available categories you have to choose from. Someone mentioned songwriter, who made the song, things like that. But they make a lot of songs. A songwriter makes a lot of songs. So that's not gonna help me necessarily. It will narrow down, but it still won't tell me what particular song I'm after in my database. Right? Yes, sir.
Is it the file name?
File name? You could do that. You could, I'm sorry?
It has to be unique, so,
Has to be what?
unique.
Yeah. So, keep in mind, remember I told you, there are certain types of data. Alphanumeric, and then string. So, when this database was set up, keep that in mind. So, like, for example, if I pick artists, I can only put what? Alpha. If I say artist, then in that field, whatever I want to put to identify can only contain alpha characters. Right? So again, which one of those fields would you suggest? I'm coming to you, you are a database consultant, right? And I'm coming to you and say, hey, I got this database. I want to be able to identify all my records, all 40,000 songs. I want to be able to uniquely identify each one of those 40,000 songs. We got a contract?
I'm between, comment and, grouping.
Okay, so I like that because comment in this particular case is a string field. Okay, so with it being a string field, I'm gonna take you to the next place. After I say comment, which I already have checked, so I have a comment somewhere here. But either way, comment is a field I could use because it's both alpha and numeric. So I could put numbers and letters in it to identify the record I'm looking for. Now, what would I put in comments to identify? How would that look data-wise? Would it be numeric? Would it be alpha? Would it be string? Would it be that you would put it? It's a string by nature, but how would you design the uniqueness of each of every song out of 40,000 songs?
And you react to that question.
Huh?
And you like react to that.
Reacts the question. What would you put in the comments field to identify 40,000 songs in this database?
BPM.
BPM, I already have a BPM field. Right here. So I wouldn't repeat that necessarily because the whole point of a database is you don't want to keep or make redundancy. So the same thing over and over again besides, what I mean by that, I already have BPM. So to put BPM in my comments, I'm kind of creating a situation where my data is being repeated too much. And I don't want to do that in my database. That's why I have a database. Right? Right?
Would it be the artist?
Artists? No, only because if I'm looking for a particular song, the artist will come up for every song that that artist made or that I have in my database. You see what I'm saying? So you gotta still drill down and make it more unique, huh?
The genre?
The genre? Well, they have a category for genre, you don't see that, but you know how many songs fit in rock? The genre of rock. So so that's why I'm challenging you to think. That's why we spending a little bit of time. I pulled up a database because I really want you to understand what uniqueness is in a database and what it means. That means it's the only record
Can we take away from what you got to do?
Yeah. You just remove the check. So I'm not gonna keep y'all guessing and thinking because I believe Sebastian had the closer answer to what I was looking for, and that's the comments. And the reason why I say the comments, I tried to give you more keys to it because the comments is a string field. So that means it'll accept letters and numbers. So what I'm getting at, if I decided just to start with the number 1 and go all the way to 40,000 as a count, you could do that in the comment field. If I was to put 1, and if you say in genre, I could say 1 HH for hip hop, 1 R&B for 1. I could do that in my database because now I'm uniquely identifying a particular record. And I can search by that, and that'll make it come out and stand out versus going, I need some Bobby Womack. Right? Because what I'll do in that case, if I type in by Bobby Womack, every song that Bobby Womack made or that I have in my database will come up. Well, what if I don't even have a Bobby Womack song in my database? What's the database gonna tell me then? What should it tell you? If you don't have it in your database, what should it tell you?
Couldn't find out.
No record found, not found, exactly. So that's how you know, oh, I don't have it, maybe I need to get it. Because that's the whole point of querying it, to see if you have it. Especially when we're talking about, if we in the middle of a party, and someone asks me, do you have blah, blah, and I search for it and I don't have it, I can't transition to the next record, the next song, by going, go get it now. It ain't there, I don't have it. So that's what I wanted to show you guys. Only reason I picked this way, because this is another way to search in the database. Now I can narrow all the 40,000 songs into stuff that's 90s R&B. If I select that, everything that'll show up in here will be only 90s R&B. Okay? So that's my point of the database. I hope this helps you because grouping is another one you could have used, right? So grouping is the same thing. You can say one and whatever. So any of these fields that are string or even at least alphanumeric, because you want to not lock yourself into just a number necessarily when you're trying to identify, okay? All right, any questions about that? All right, so I hope that helped you some, and let's see what else I have. Anything else unique? Oh, with a database, so that's all. So those are all the songs, but also I can create as many of these folders as I want. So when I do parties, for example, I start off with a blank form, basically named after the person that's giving me the business. Then I start dropping songs into my folder. And that's how I build a lot of my playlists for my parties. I can see doing it easier another way. Anybody got another way, a better way, besides a database to drop songs into a folder? Yeah. That's right. So that's what I'm saying. So that makes it easier. So I thought this would be a good way to kind of explore a database and how it should work for you. Because not all databases work like this, but I can query. So up here, see this? Search. I can search in that folder, whatever folder I pick, I can search whatever. So, just an example, I'm just giving you the query function of a database so you'll know. And I don't know, let's just say Bobby. What does it tell me? Anything with Bobby in it, right? And that's what a database is supposed to do for you when you search it. So that's why sometimes you gotta narrow your search down when you're getting a whole lot of results. So if I was to say Bobby Brown, it would shorten this list, right? Or it should, it's supposed to. See how short that got? So I can go Bobby Brown, Roni, and it'll only pull up that one. But my point is a database, you want to search for songs because you don't know exactly what song you want necessarily from, let's say, Bobby Brown. But when they all come up, as a DJ using this database, if I'm playing something already at one of these BPMs, I would pick something closer to the BPM I'm already in to make it make sense. But that's the use of a database. That's how you use a database. And especially this one, because this is my favorite database out of all my databases. So I'll leave it at that. Hopefully you get the gist of what I'm portraying and how you should be using any database. Not anything in particular, but you should be able to search it. You should be able to add to it. You should be able to modify it. You should be able to identify a record in it. You should be able to do all of this in a database. Okay? All right, so the next thing, we're not gonna do that. So I'll show you a video now, basically, about what we kind of discussed database-wise. I'll show you that. Because I watched it actually before, yet last night I watched it, and it's pretty interesting. Then you can see what I talked about, what I didn't talk about, what I didn't go over. But I don't go over every single thing. I just try to go over the things that we could have a good discussion about. Okay? So, with that being said, so I don't know if anyone has seen this already, because part of your paid subscription, you have access to all of these videos.
Organized collection of information on a computer.
So,
Any kind of information you can think of can be stored in a database.
alright.
We're going to learn about databases. At its most basic level, a database is an organized collection of information on a computer. Any kind of information you can think of can be stored in a database. Names, dates, files, pictures, transactions, comments, messages, numbers, the list goes on and on. Data is a vital part of any organization. By using databases to collect, store, and retrieve data, businesses and individuals can make informed decisions and plan effectively for the future. There are many kinds of databases. Each type uses a different technique and serves a different purpose. That said, almost all databases share the following characteristics and features. First, centralized access for multiple users. Most databases need to be used by more than one person, so they allow many individual users to access the data at the same time without having to wait or take turns. Second, security. Databases have measures in place to make sure only authorized users can get to the data. Additionally, different users have different privilege levels. While a top-level administrator can view and edit all the data, lower-level users may be able to see records but not change or delete them. Third, recovery. Information contained in a database is valuable, and losing it could cause irreparable damage for an organization. Databases are easy to back up, which means the data can be restored if something goes wrong. Fourth, scalability. Databases may store thousands, millions, or even billions of data points. Imagine keeping track of 1 billion rows on a spreadsheet. Not very easy. Fortunately, a good database makes analyzing 1 million records just as easy as analyzing a few dozen. Each database is managed by a software package called a Database Management System, or DBMS. The DBMS determines the format and structure of the database and provides users with tools they need to work with the data. In this course, we'll use a DBMS called Microsoft Access. We chose Access because it's a great introductory tool for learning how databases work. It's also sometimes used at very small companies where only a few people need to use the database. That said, most companies need a DBMS with more features and security. Some of the most common ones are MySQL, Oracle Database, and PostgreSQL. In today's world, databases are everywhere, and most people use them every day. Don't believe me? Let's look at a typical Friday evening and count the databases. On the way home from school or work, you stop by the grocery store. You scan each of your items using the self-checkout stand, swipe your loyalty card, and pay with your debit card. Once you get home, you go to your favorite pizza chain's website, place an order from their online menu, and pay with your credit card. While you wait for the pizza to show up, you check your favorite social media platform, then browse for a good movie on your favorite video streaming service. In the course of about an hour, you seamlessly used 7 databases.
All right, so with that being said, now hopefully databases look and feel different because now you see how they're used. I use it in a DJ setting. All of those checks for grocery and all those databases. So what does that say to you about data? How does that speak to you about data and how much data is out there and how we use this stuff? Really unknowingly sometimes when you're doing that. Did you know it goes through all these databases like that when you're doing certain everyday things? I would say not. You don't. Because there's not be a lot being taught on databases. AI is a database, okay? So every time you say something to AI or ask AI for something, you don't think that it's storing and recording that? It is. Because sometimes, because the nature of AI is new, it's more apt to give you a better result when you're talking about something current. You go ask about the Flintstones or Felix the Cat and all these cartoons, it'll take a little bit longer to search that for that information, but it's not as current. And most people are not asking those kind of questions. You know AI has to be trained, right? Everybody does know that, right? Yeah. So when you first get a piece of, I call it AI software, you have to train it. Where I work, we have a, what is that thing called? My dad put it when he first got it. But anyway, it's like a virtual assistant. So with the virtual assistant, my assignment was to teach it, tell it, show it, demonstrate a lot of our processes. So that way, that virtual assistant was tied into our call center. And when it tied into our call center, we get all kind of questions being asked of the virtual assistant in our call center. So any odd, out of the way question, I had to come up with odd, out of the way, probably most of the time not even relatable questions, so I could train the virtual assistant how to navigate a question that it has not heard before, or something it doesn't know about because we haven't trained it yet, okay? And so we're getting closer to not having to ask or train it about certain things in certain places in certain areas, because we feel we've done a pretty good job of training it to what to look out for when it comes to the type of questions that it should be answering from our line of business. Students, scholarships, we got a lot of programs, so. So to me, that database is just gonna grow. And what did I say earlier about more data when you get data in a database? What's the most important thing? Really? It's not even the data, so don't say data.
Organizing.
Organizing it and having the capacity to store all the data. Because guess what? At a certain point in time, if you cross a threshold when it comes down to not having enough data, guess what you're gonna do? You're not gonna have that data. Because you can't store it nowhere. It can't save it nowhere. So now your AI or your storage or your database is kind of ineffective. It has a lot of information in it, but what about this other stuff? Because you done ran out of space. So that's your biggest concern. And in any corporate setting, your biggest concern is management or of storage of your database. Most important item, okay? All right, so with that being said, we're gonna move on. If I can find my mic. There we go. All right, now, that's what a database is. So, anybody ask you, what is a database?
Collection of details.
Okay, all right, good. So then they probably will say, well, details of what?
Information
What kind of information?
about their statistics and attributes and facts about people and things.
Okay, so if that's the database you're talking about, so it's gonna relate to the type of database that you're actually referring to. But as a rule, database is like Kevin said earlier, it's just a collection of information, and that information will matter on what you need to use it for. That's what's important, because that's what's going to be contained in the database. And if you know that piece, you can answer any database question
Also,
by knowing that. So-
also structured set of data held on a computer.
Yep, so like I showed you, it's structured because it had a column for everything. Same thing in a regular database. That wasn't a regular database, that was a DJ database. So I just used that to show you the power of having a database and how you can use the data, is the reason why I showed you that. The databases look different. Not all databases are or look the same, okay? So just keep that in mind. Any other questions about databases? All right, so this last video I think should suffice. It's only 3 minutes.
A database management system is software that creates and manages databases.
So stop. The first video was just databases. This is DBMS, Database Management System. It's a difference between the two, just so you know before we get too started. All right, so here we go.
It acts as an interface between the raw data stored in the database and people who want to use or analyze the data.
I appreciate that.
Could restart it so we can,
Okay, there we go.
now talk, homie.
Now you good.
A database management system is software that creates and manages databases. It acts as an interface between the raw data stored in the database and people who want to use or analyze the data. Using a DBMS, people can create, read, update, and delete data. Common database management systems include Microsoft SQL Server, Oracle Database, and MySQL. Another DBMS you may encounter is Microsoft Access. Access is much less powerful and versatile than the other systems we mentioned. A typical Access database is used by only a small handful of people. That said, it's an excellent tool for teaching foundational database concepts. In this video, we'll look at a simple Access database and discuss 4 database objects: tables, queries, forms, and reports. Tables form the backbone of any database. This database has 6 tables, each with a different kind of data. To open an Access table, double-click on it. This table stores information about our employees. We have their names, which of our 3 locations they work at, their hire and birth dates, and their home addresses. The products table has each of our products, as well as their product types and prices. The orders table is a little bit different. Rather than having its own information, it takes information from the 3 other tables: the employees table, the customers table, and the products table. Using this table, we can see which employees have sold which products to which customers and the date of the transaction. To close a database object, click on this X. The next database objects are queries. I like to think of queries as questions I may ask my database. For example, I might ask, how many sales have we made this week? A query can instantly collect all of the data I'm interested in from my tables, as well as performing calculations on it. This query shows each day of the past week, along with the total number of sales and the money made from sales for each day. Queries are also a great way to see data from different tables. This query combines related data from the employees table and the employee phones table. Next are forms. Forms provide a convenient way for users to enter data into their tables. This is especially helpful if multiple people are using the same database, because forms reduce the chances of making data entry errors. They also help prevent users who don't understand how the database works from changing important settings on the tables. Last are reports. Reports provide good-looking printable summaries of your data. They can be based on tables, queries, or both. Some reports also contain summary information. This report breaks down the restaurant sales by product type. For each product, we see the amount sold, as well as the total revenue for that product. At the bottom of the page, we have the total sales of the entire database. In this video, we discussed database management systems. We also used Microsoft Access to look at 4 database objects: tables, queries, forms, and reports.
Okay. We kind of went over that during class, a lot of that, because we were discussing, but, something I wanted to say about it.
So that'll do it, Mr.
Say
Edwards?
Say it again?
That'll do it, Mr. Edwards?
No, not just quite. Unless we have questions, any questions? So that's databases. What do you think?
Yeah, use database to get information about someone or something.
Okay, do we care?
Yes.
Why would you use a database?
To learn something, well, what's going on in the future,
Okay,
or in events that are occurring,
okay,
to figure out what is happening around.
okay. So I'll be more specific then. As a teacher, how would I use the Gwinnett Tech database?
What are you trying to do?
Okay, again?
For questions.
So what questions? So as a instructor, I use the database. So typically when you have questions, or if I use the database to see who hasn't done their work, because that's easy for me to use as a database. And then from there, I can know to look for an email from a student. That's one way I could use it. I could instruct this, I can send a student an email depending on my time and say, hey, I've noticed that you missing blah, 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 and blah.
Usually give somebody F, drop it from the class.
Now, I usually don't give people F, they earn it.
Earn an F. How you earn an F?
You earn that by not doing the work.
That's true.
That's how you earn it. Don't do the work in this class, I guarantee you it will earn you an F. That's almost permanent. But my point is I try to get in a space where when I have time, I can send the student, if there's, because it's the student's responsibility to check their information. It's not my responsibility to go, oh, you're missing this, oh, you're missing that, oh, you're missing this. You got the tools to find out what you don't have or what you do have. It's called a grade book. And if it's a 0 in a grade, I have seen some students look when they have not completed an assignment, and they'll come to me and say, hey, or send me an email more importantly, and say, hey, these are the things that I'm missing. When can we discuss catching up, basically? If a student asks me that, then we gotta come to a time that we can discuss that, right? And once we discuss that, then the point is, I know and you know what you're gonna do about it. And here's your plan. If you talk to about plan, here's when this is due, since it's already been missed. I don't have no problem with that if a student comes to me and asks that. I'm not reaching out to the student and say, hey, I'm gonna give you the opportunity to make this up. That's not my responsibility. I will send you an email. Matter of fact, Gwinnett Tech does a great job using a database to send stuff out to students that are already looking like they're failing. That's a good use of a database. So that way, at the end of the day, when it's getting crunch time and we a week away from finals, then the student comes and says, hey, is there any way I can make up the work I missed? My answer is, you had the whole entire semester. And I don't, it sounds rude and harsh or whatever, but if you wanna wait till the last week to handle your business, I'm sorry, that's not something that I should be put under due rest because you waited the whole entire semester to now want to catch up. That's only fair to me, and it's fair to you because you had the opportunity. So I hope everybody understands that, and that's kind of how we use databases for good and bad. But the point is, you gather enough information and you can send the information to who it affects. And that becomes your get out of jail free card. So if you've already emailed me, let's say, and I haven't responded, that's in the database. So now it's not on you no more. It's on me, because now you got a copy in the database of an email you sent to me saying, hey, instructor, what about this? And I never responded. That's simple. And usually if you show me that email, either I missed it or it was a one that's missing, because sometimes students have a tendency to show only the email that support what they did, not what the instructor did. And that's where they usually get caught up in their appeal. I've had my whole time teaching 10 years, I've had 2 students appeal. That's it. And that was really because of a miscommunication when it boiled down to it. But at the end of the day, I listen to what my academic advisory says. If they say let the student do it, who am I? I'm just reporting what is occurring in the class. And all this is in a database. So it can be pulled up at any given time. So I don't understand why a lot of times when students know that they haven't done what they needed to do, they still want to fight the power. And it's just inevitable. At the end of the day, either you did it or you didn't do it. And let the record show it, you know. But that's all I really have. We're getting close to finals. So I'll say this again. If you're in here and you've taken the midterm and you didn't come to class to take it, I found out that you don't have to come to class to take the midterm. You don't have to do that, and neither the final, just so you know. I may have told you something different because I was told something different, and I just got corrected with midterm. But please understand, if you are taking it at home, you gotta have lockdown browser, and you got to record, and you gotta take a legible picture of your photo ID. Because I know who you are when I see you in class, but I don't know who you are when you take it. I could see you there, but I need something to say. Here's a picture, and there's a name. Oh, yep, that's who that is. And if that's not happening, I'm going to send you an email saying you did not complete the final at this point using the lockdown browser. You have to come in on campus to take it, right there in the computer lab. Yes, sir.
They didn't make me
It didn't make you use your ID. I didn't send you an email. So check for your email, check your junk mail, because usually I go through it and I have to review them. That's the whole point. I have to review them before I can finalize that grade. If I don't review them and I don't have that information, regardless of what you make on any given test, I'm making it a 0. I'm overriding that because I gotta know that you took that exam. Yes, ma'am.
So the final was just like the midterm that we took last week.
I can't.
The final was just like the midterm that we took last week, right?
Yeah, so with the final, because it is a week long, Saturday is the last day. So if you are a student that want to study to the last minute, that's fine, because you can come in here and take it. Even if it's the last day and you decide not to get up that morning and take the final exam at 10 o'clock, you still got to figure out a way of how to get to the lab sometime during it. So you need to know what the lab hours are. They are open on Saturday.
So you can't take it at home, but with the lockdown browser, right?
You got to take it at home with the lockdown. Yep. And you got to take a picture. A legible picture. I've had students take pictures. The pictures turn. They taking the picture, and the photo is pointing this way. I see a picture of their arm, but I'm like, really? What? So anyway, so I send them an email. Look, I can't see it, and sometimes they'll take it. It's so far away. They'll hold it right here, and it's so far away from the camera. I can't see the person, or I can't see the name. So please, when you're doing that, push it up to your camera. You know what I'm saying? Make it where and besides that, before you even send it to me, you can see what it looks like before it even goes.
Yeah, you check it before.
So please do that, because if not, you're just gonna delay the process. Because if I can't see it, I'm just gonna say in an email, hey, I need a copy of your photo ID by certain time. And if you don't give it to me by certain, especially with the final, because we don't have a whole lot of time between the time we gotta report the grades and I'm waiting for your ID to come to me. And if it's in that period of time, then that's gonna be a discussion you have to have with academic affairs, because I'll be doing my job. You didn't report to me the picture that I asked you for within the 2 days, and so that's how it became a 0. Now, I can put it back if I get the information, but I'm not, I'm not gonna not do my job.
And take the picture or something?
Say again?
Like go back in and take the picture?
No, you really, if you've not taken it right now, for example, just take a picture of your ID right now and send it to my email. And that's fine. You don't have to go back in. You just need to get me a picture of your photo ID that I can see and read. So it's not required to go back into the test. You don't have to do that. I just need that photo ID. And you can just send it to me in an email. So that's important. Any questions?
You gonna be here for final exam?
Yes, I will be here.
I'll probably come in.
Yeah, I mean, because it's your option, but because you signed up for a face-to-face class, I have to be here for the final and the midterm. For a student that is not going to take and do the lockdown or whatever, they're not going to go through all of that. So they just come in, it's easier just to come in
It's
here.
easier just to go ahead and do it right here.
Yeah, but people think different. I can't tell a person how to do it. If I say right now, everybody got to come to class and take the final exam, it's not going to happen, because I did it for midterm, and a lot of students didn't come. And that's when I found out the student didn't have to.
But they gonna know this is a hybrid course, I don't have to.
Yeah, and I don't care. Look,
Your
I don't care either way. You got to take the exam regardless, one way or the other. You got to take it. So if you want to jump through hoops to take it, or you just want to come in classes to take it, whatever. It doesn't create an attitude for me because you took it at home, online, whatever. It doesn't create me having an attitude. That's the way you prefer to take it. Well, I don't have to take it, so so whatever suits you. So that's it. Unless you have any questions, you can